So, I welcome you all to this session of Production Management and Operation Research AV606HU. Today we'll be discussing about network scheduling. So, the basic lecture of this network scheduling part will be dealing with the basic terminologies of a network. How do we construct a network? What are the relevant terms that combines the network? That would be our primitive discussions. So as you can see, network scheduling is our topic today. This is the first lecture. We'll have three lectures. Okay, so this is the first one, the basic terminologies of network and how to create the network diagrams. Myself Arindam Mukherjee, Assistant Professor of Automobile Engineering Department, Dr. Sudhit Chandra Shur, Degree Engineering College, which is under the JS group. Okay, so let us move on to the objective part. Let us see what are the objectives of this lesson. So let us just a minute. So as you can see, we'll be introducing the different network terminologies. Okay, we'll be discussing the various terms that govern the network. How do we construct a network, and what are the terms that are influencing this construction of networks that will be discussed here. We will be discussing about the various techniques of network scheduling. We'll discuss what is network scheduling, how do you schedule a huge project. Huge project means where there are a lot of activities, included. So we have to keep in mind that all the activities has to be scheduled in a perfect way so that the projects can be completed within a certain due date. And we will, so this is the main attraction of this lecture, how to draw these network diagrams. That will be our basic discussion today. So this is my objective today here. Now let us, so now we'll be discussing about the outcome. What are the probable outcomes, or what you will understand after this lecture ends. So I hope that you will be able to understand the fundamentals of network scheduling techniques. That means, what do you mean by network scheduling, why it is important, where it is required, and how this network scheduling affects the performance of an industry. How does it reduce the cost? How does it affect the performance? How does it affect the industrial perspectives? That is the most important thing. I hope that you will be able to understand all the network terminologies which will be discussed later on. And the most important thing is that according to a certain problem, you will be able to understand and you will be able to draw the network diagrams accordingly. So we'll be discussing this network scheduling. So as you can see, there is something written over here. I provided these notes to you so you can read it over. Just I am just repeating these things, and let us just discuss and understand what does it mean. So network scheduling is a technique which is used for planning and scheduling large projects in the fields of construction, maintenance, fabrication, and purchasing of computer systems, etc. It is a method of minimizing the trouble spots such as production delays and interruptions by determining critical factors and coordinating. So, as we are discussing, so you can see that whenever you need to plan some projects, a project means it is a combination of numerous activities. Suppose you have to produce a certain machine. So any machine is a combination of different parts. Okay. So if you wish to create that machine, what you have to do, you have to purchase some materials, and there will be some devices or some parts of that machine which you can produce by yourself. So there are two things here. One part is that you are buying some materials from certain companies, and the second part is you are manufacturing by yourself. So now what you have to do, you have to combine these two factors. You have to combine these two factors. Okay. Now you must understand there will be a lot of activities going on. So first of all, there is a coordination which is extremely necessary, and then you have to schedule these activities in a specific order so that you can properly utilize your time, so that no time is wasted. So here comes the importance of network scheduling. That means you are scheduling the various activities involved in a certain project in such a way so that there is min- the time loss is minimized here. Okay, so here are some examples, like in case of constructions, in case of maintenance, in case of fabrication. So there can be another examples also where you will find you you need this technique of network scheduling. Okay, so here you can see scheduling. Scheduling consists of the activities according to their order of precedence and to determine the following. Okay, the start and finish times of each activity, the critical path on which the activities require special attention, the stack and flow for the non-critical paths. Now, see, you're just finding some new terms here, like start and finish times, like critical path, like slack, like float. So you don't know those things. Now let us discuss what do we mean by start and finish times for each activity. So what do you mean by activity? Activity means that suppose you have to grind a job. Suppose a specific dimension is given to you and you have to grind that job. So let us draw a figure like this. Let us say this is 1, this is 2, and this is A. So there are three alphanumeric characters, 1, 2, and A. Now when you are trying to grind the job as required, as per your requirement, you have to first fix the job, then you have to operate the grinding machine so that the job is grinded to the specific dimension. So until and unless you have fixed that job to the grinding machine, the time calculation required for grinding doesn't count. So when you have fixed the job, that means you are starting from here. Now here, that means at point 2 you have received your dimension. As per your desired dimension, the job has been finished. So this is the starting point and this is the finishing point. Okay, and in between you can find that an activity has been completed. So what do we define these two things? They are called as events. Events. So as from this event, from the event number 1, the whole activity is starting, it is called as starting. S. Okay, I'm just giving the S here. And this is the finishing activity. Sorry, finishing event. So here you can understand So now you can understand. So this is the starting event and this is the finishing event, and combination of these two events, that means combination of the starting event and the finishing event, gives you an activity. So what you need to know while discussing these scheduling problems, you need to know the starting time for this event and you need to know the finishing time for this event. That is where it is required. Okay, so I hope you have understood. So you will deal with the critical part later on because it will require some time, and we'll discuss the slack and float part also later on. Now see that mm, here you can write, here you can see that activity represents some action and it is a time consuming effort necessary to complete a particular part of the small project. That means a project uh, is a combination of numerous activities. Okay, so so we had discussed about this activity thing, and now we'll be discussing about these events. So as you can see, an activity is comprised of two separate events. Okay, so this is the first one and this is the second one, as I just discussed earlier. So starting event and finishing event. Now you have to remember that no event consume time. It is the activity which consumes time. That means when you are required to complete an activity, you will require some time. But there is no time allocation or time consumption for any event. Okay, so event doesn't consume any resources or nor it doesn't and it doesn't consume any time also. Okay, so sometimes this is called as head event, this is called as tail event. Okay, so now see, this is a specific event. Okay, let us assume uh, let us assume that three different events three different events are getting merged into a single event here. So that means this activity, I'm very sorry, this event is called as the merge event. That means where some some events are getting merged. Okay, so you can say somewhat like that, which is written over here. If an event is the ending event, even event is the ending event for two or more activities, that means the activities are culminating to a specific point, they are meeting here. Both see, you can see that the three activities are getting are merging here. So this is why it is called as merge activities. And similarly, suppose this is an activity event. From here three different events are being generated. So this here, this will be called as this burst event. Okay, so that means in case of burst events, this will be the starting of different events. This event, the burst event, will be the starting event for different other events, whereas in case of merged events it will be the ending event. So if two or more events are getting summed up to a certain event, then it is called as merge event. But if numerous events are being generated from a single event, then that specific event is called as burst event. Okay, I hope I have made you clear, because you have to understand this thing very minutely. So burst event and merged event. Okay. Okay. So now we'll be dealing with two different activities: preceding and succeeding preceding activities and succeeding activities. So you know the meaning of the word preceding. That means something precedes something. So we are talking about an activity which has to be completed earlier. That means you cannot proceed to an different activity if the certain activity hasn't been completed. So to move on, to move on in the project, to move on in the project purpose, there will be some activities which has to be completed. If not completed, then you cannot proceed further. So these activities will be called as preceding activities. Activities that must be accomplished before a given event can occur are termed as preceding activities. Okay, so activities, similarly we'll be discussing about these succeeding activities. Activities that cannot be accomplished until an event has occurred are termed as succeeding activities. So that means you cannot suppose, just I hope this diagram will help you to understand. Just give me some time here. Okay, let us take this one. So you will find an error here, but to understand what is preceding activity and what is succeeding activity, we'll discuss. Suppose uh, this activity B. Oh, okay, before that, always remember, activities are always represented by alphabets. It is a general notation, you can change as per your requirement, but generally you'll find activities are being termed by the alphabets, whereas you'll find the events are termed by the help of numerics. Okay, like the numbers. Now here you can see, let us focus on this event. So from this event you can see that there are mm, two activities which have been generated, that is activity B and activity C. So when this A and D haven't been completed, you cannot start this B and C. So these A and D activities are the preceding activities of B and, say what else, C. So A and D are the preceding activities of B and C. Similarly, B and C are the succeeding activities of A and D. So I hope that I have made myself clear. A and D is the preceding activity of B and C. B and C are the B and C activities are the succeeding activities of A and D. I hope this is clear. Now, now there will be something called concurrent activity. Concurrent activities. You will find something like that. Concurrent activities. So that means in case of concurrent activities, these activities can be accomplished concurrently. That means they are going on simultaneously. So there is no such condition. That means you cannot move on to this activity until and unless that activity has been completed. Such type of compulsion is not given here. That means you can always move on and the activities will be generated and we will be so that means the activities will be happening simultaneously. They will move on, they will take place concurrently. Okay, now we'll be discussing a very important thing now, which is called as dummy activity. Dummy. So you can understand what does the word dummy means. You know, I hope. So from this basic meaning, you can understand what are the importance of this dummy activity. So this dummy is needed when you are trying to fill up a certain gap. Okay, you are giving some dummies to complete certain schedule, complete certain network. That means this this is a completely mathematical concept. That means you are introducing an activity which is not consuming any resources and it doesn't consume any time. Okay, you are just providing this dummy activity to maintain a certain order of this network. Okay, like here you can see this. Suppose there is a condition given to you. This D activity can only proceed if B and C has been merged to this, let us say, event number 1. So this is the condition given to you. Until and unless B and C activity merges together, so as we are discussing, that if there is a compulsion that B and C has to be merged at a certain event and then only D can start, then you have to connect these two activities by the help of a dummy. So this dummy activity is not shown in a continuous line, it is given in an intermediate line. Okay, so I hope you have understood what is the purpose of dummy activity. It is only to, it is only given to connect the networks. Okay, now there are some common errors which you will find while creating the networks. Let us discuss them. So the most common of them is looping error, where let us see this image. Here this is the direction, this is the direction, and this is the direction. That means they are moving in a never ending cycle. So this is what we call as a loop. So whenever you will find a loop has been created, that means you have to understand there is something wrong in this network. So you can't allow a loop to be formed in a network. Okay, now you will find an activity which is left out without being connected with a certain event. So this type of errors is called as dangling. So this is called as dangling. It means there will be, you will find an activity where there is no finishing event. So it is left of the network, and you will find there is another thing which we call as redundancy. Okay, so let us move on to that thing. So here, okay, now here you can see there are two separate networks. Now, like ABC, these three activities ABC, and here DEFG, they are constituting two different networks, and you are connecting these two different networks by the help of a dummy activity. Okay, so here comes the reason. If a dummy activity is the only activity emanating from an event which can be eliminated, then it is known as redundancy error. Okay, so that means you are connecting, that means this is not required. From here you can generate D, you can generate E, like something like this. If it is, so let me just draw it. C. So this was A, this was B, and this was C. Now here what had happened, you have to, you are connecting this event with this event by a dummy activity. Now you can easily remove this error if you start the activities D, D and E from here. So that means you can easily reconstruct the network by removing this dummy. So this type of error is called as redundancy error. So this is not allowed while forming a network diagram. Now here you can find there is a dangling error present here, because you don't find, you, you can't find the finishing event here. So that means here in this network a dangling error is also present. So we can we are able to solve the redundancy error, but we can't solve the dangling error here. Okay, I hope you have understood what do we mean by the common errors in while network scheduling. Now there are some, problems, or there are some rules. We will not read those rules, we'll just try to understand how do we construct networks. Okay, so better to understand uh, doing the things. Okay, we will try to do the construct the networks, and thereafter we'll try to understand what are the rules. I hope that if we are able to understand how to construct the networks, we will able to understand the rules also. So let us look into a problem. Construct a network for the project whose activities and precedence relationships are given as below. Now here you can see activities and immediate predecessor. Okay, now what do you mean by immediate predecessor? I hope all of you remember the concept of preceding activities. That means until and unless a certain activity has been completed, you cannot move on further. So here comes the relationship of preceding activities. Okay, so the conditions are given here, like B. Consider the activity B. It has a preceding activity of A. That means until and unless A has been completed, this means that until and unless A has been completed, this B, and similarly this C can't start. That means the relationship suggests that these two activities B and C has to be generated from their immediate predecessor. Now if you just, first of all, you have to look on to the whole problem, right? Because this will help you. Now see that you will find that A and D doesn't have any immediate predecessor. That means they are generating from a single event. Okay, they are generating from a single event. So this means that they are generating from a single event. So let us write down A here and D here. So this is the first step which we understand from this relationship. Now see, I hope you understood this thing. A and D doesn't have any immediate predecessor. That means there is no such conditions which are being applied on these two activities. That is this A and this D. So there is no such conditions applied on A and D. So A and D can be generated from this event. Okay, so this is why we have generated this. Now let us use a different color here. Now see, both B and C have the same predecessor. Okay, they have the predecessor as A. So that means B, B and C has to be generated from A. So this is what the condition means. So whenever you will find an immediate predecessor is given to you, that suggests that the activity has to be generated from its immediate predecessor. So as it was given B and C are the B and C both have A as their immediate predecessor, so we write this B and this C here. Now we are leaving these circles blank, so we will deal with later why we are leaving it blank. So there is a important point to understand also there. Okay, so let us just clear this all. So now you can see that we have completed till D. Now here E. E has the immediate predecessor as D. That means this E has to be generated from this D. This so this E has to be generated from D. Now see, let us come on to this activity. This F has its immediate predecessors as B, C, and E. Now you have to understand here. Here you can see three immediate predecessor. So this suggests these three activities B, C, and E, they has to be merged somehow. Now according to our network, there is no such condition. We are not we, what we have drawn till now, we'll see that there is no chance that they are going to merge. Now here some alterations are required. So while you are giving your exams, I suggest you use a pencil while drawing this network, because there has to be some modifications, and you have to go through this modification, because there will be changes all along the process of drawing this network. So my suggestion is to use a pencil while drawing. Now what is the change we are going to do? We are going to merge this E here. So here we can see that C and E is now getting merged to a single event. Okay, so this is the thing we can do till now. So here we can see C and E has been merged. Okay, now can you I believe there is no chance, there is no way out by which you can merge the three activities. That means what I am trying to say is that you cannot merge B with the two activities C and D. So here comes the concept of dummy activity. So that means you are using a dummy activity here. So now B, C and E has been merged. They has been they have been merged together. Okay. Now you can generate, now depending on the direction, now depending, I am very sorry, the direction will be not like this. This has to be like here. So that means B, C and E is getting merged here. Okay, now you can generate a separate activity F. It is right, F over here. So now you can generate an activity F which certainly follows the conditions of immediate predecessor, as F has the immediate predecessors as B, C and E. Here you can see that B, C and E are getting merged here. Okay, so now move on to G. G is being generated from F. Okay, so let us use a different color here. So G is being generated from F. So I hope you understood till now that the immediate predecessor is what from which the activities are being generated. So if you know the immediate predecessor, then you can start on an activity. Okay, so you can start on an activity. So let us move on to H. Now see, H is H has the immediate predecessor as D. So that means from D this H is being generated. Now this H can be here, this H can be here, whatever you like. But you have to look on to this condition. This I can be generated only if this G and H are being merged. Okay, so what we we do what we will do, we will just remove these two things here and we will merge it here, and now you can generate the activity I. Okay, let us not do it here because it will cause some other problems. What other problems? It will create a loop here, here and here. So it will create a loop, so we can't allow it to happen. So let us leave it, let us just leave it here. Mm, it is just taking time, please pardon me. So leave it here. So this is what is I. So now you can find the network has been constructed. Okay, I hope you are able to understand how do we construct a network. So the things you must understand is that if there is a relationship given as active, so if
The relationship is given by the activities and their immediate predecessor. It suggests that the immediate predecessor is the activities from which this these activities will be generated. So this is the hint. So like B has to be generated from A, C must be generated from A, but B and A doesn't have any immediate predecessor. So that means they can be generated from a, there is no such compulsion here. Okay, now here, now why, I just, if you remember, I just said uh, 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 after before some moments, I just said that you have to look very seriously, you have to understand the nature of the problem. What are the combinations given over here, what are the equations and the relationships are given over here? So that becomes very important. So if there is a condition like this, B, C and E are the immediate predecessors of A is given, then you have to understand this B, C and E has to be merged together. Somehow they has to be merged together. Similarly, there is a condition here, G and H, they have to be merged together. So this is why you will find here G, I have just forgotten to write H here. So GH will be merging here, and B, C, E and E were merged together here by the help of dummy activity. As we don't have any other option to connect them, so we were compelled to use the dummy activity. But you will, but it's a suggestion, try to avoid dummy activities. If there is no way out left, then you have to obviously use dummy activity. Okay, now if you remember, I told that I am leaving these circles blank. Why it is blank? Now I am just going to fill it up. Now see, the alphabets in the network diagram represents the activities. The numbers in the network diagrams represents the events. So I am just going to fill up the events. Like here I am giving the number 2. So this activity A can also be represented by this. So 1 to 2 activity means, it means activity A. So this is, these two things are synonymous, they mean the same thing. Okay, so only you are using the numbers here 1 to 2. Like similarly, if we write 3 here, that means 1 to 3 means that this D activity. So here you can write 4, you can write 5, you can write 6, you can write 7, and you can write 8. So there are total 8 events, and you will find there are 9 activities. Okay, so this is the basic primitive concept of drawing network diagrams. I'll be discussing another problem. Okay, so let's stick to that, and then hope the concepts which you are not able to understand, this will help you. Now similarly here also the same relationships are given to you, like an activity is given to you and the predecessor activity is also given to you. So you have to keep in mind the relationships between the immediate predecessor. Now see, A, B and C doesn't have any predecessor, so that means they can they can be generated from anywhere. So let us write A, B and C. So you can start to fill up the circles while drawing the network, or you can do it later. So let us just write A, B and C. So I am just doing it now. 2, 3, and 4. Okay, now see, this activity D has been generated from A. Activity D has been generated from activity A. How do you understand it? It because the preceding activity of D is given as A, the predecessor of D is A, so it will generate from A. So just write down D here and write 5 here. Okay, so we are done with the activity. We are done with the activity D. Now let us move on to E. Okay, so E and F has the same condition. Both of them have B as the immediate predecessor. So what is the relationship here? Both E, let us just write E here, and F. So write 6 here, write 7 here. So E and F are generated from B. Okay, it is very simple. Okay, now similarly, in the next part you will see that G has been generated from C. G has been generated from C. So just write G here. Okay, it is very easy, I hope. So G has been generated from C. Okay, so we are done with G. Move on to H. H has the immediate predecessor as D. So from D it will be H. Okay, now I has been generated from sorry, I'm very sorry. I has been generated from E, and in the next column you'll see the activity J has the immediate predecessors as H and I. That means you if you want to generate this J, then you have to merge H and I. So this I was generating from here, so let us just write I, and now you can generate this J. Now you can generate this, I'm sorry, very sorry here. So you can write J here. Okay, and similarly now you will understand this F and G need to be merged. So we have just left it now, but still there is a chance that we can uh, uh, there is a still there is a chance to clear that error which we had. So let us just write G here, and now you can see that this G is being F and G, they are being merged to this even number 7. Okay, and from that you can you can generate the activity K. Now just merge it here. So always remember, our primary motive is to uh, create a closed network. Okay, we'll always try to create a closed network. Always remember that. Now see, so what I was doing, I was just writing down the numbers. Okay, now see, in there is a problem. Here you can see that the event number 8 is missing. So that means you have to clear that error. That is why I have just told you to use a pencil while drawing this network, because there will be lot of modifications which you will need to do. Okay, so 5 6 7, that is all correct. What we have to do, we have to just write 8 here and just 9 here. Now you will see that the network is complete. Okay, so always keep a pencil with you while drawing the networks, because you will need to do a lot of modifications while drawing this network. Okay, I hope you have understood how to draw networks. Okay, so there are some assignments provided to you to solve, to understand the problems. I don't have any problems with me now, presently now, but you have to solve the assignments, and afterwards we'll discuss if there is some problem, because in the next lecture we'll be dealing with the scheduling techniques. So we have two different, sorry, so we have two different scheduling techniques. One of them is called as CPM, that means critical path method, and the second one is PERT or PERT. Okay, so we'll be dealing with these two things, these two scheduling technique, in the next two lecture. So I hope you have understood the basic terminologies of a network, and I hope that you have understood what is a requirement of scheduling or creating networks, and most importantly, I hope that you have understood the techniques how to draw the networks. So this ends here. So let us move on to the we'll be moving on to the next lecture. I hope if you have any problem, you can mail me, you can raise your comments in the Google Classroom, whatever you wish. But I hope I have made myself clear and you have understood this lecture. Thank you.